Hello and welcome to this edition of the virtual Eric Miscoll Show. This will actually be the last edition for 2020. And I think we can all agree it'll be good to put 2020 in the rearview mirror here. So as always, I'm joined by Phil Stoten, who's doing extra duty, waking up at 3 in the morning in Melbourne, Australia to join us today. So thank you, Phil.
You're welcome, Eric.
Our topic today is autonomous manufacturing as it relates to the EMS industry. The concept of autonomous manufacturing is becoming a reality in the EMS industry, and more companies are certainly emerging in this space. And so to provide some insights on this, we've invited two visionary founders and CEOs of companies in the industry. So today joining us is Theo Saville of CloudNC and Yoav Zingher of Launchpad. Gentlemen, thank you for taking the time to join with us today. Why don't we begin by allowing each of you to introduce yourselves and your company for the benefit of the audience. And Theo, since I named you first, we'll go with you first.
Sounds good, Eric. So, hey, I'm Theo, co-founder and CEO of CloudNC for just over 5 years now. And in short, our mission is to make manufacturing autonomous. And what does that mean? Today, manufacturing is automatic in that we can program machines. We as humans can create instructions and tell machinery how to do something, and machinery will follow those instructions over and over again, blind and deaf to the world, and make products for us. But as soon as we want to make something new, you need to get armies of expert humans involved to reprogram your machine, reorganize your factory, whatever. What we really want is autonomous manufacturing. I tell a factory, make something new, make something you've never seen before, and it knows how to do it better than you or I ever could, and can do that infinitely flexibly within the capabilities of the equipment in the factory and eventually within the supply chain. So CloudNC was founded in order to bring that goal into reality. And where we've started is with the machines that I'd like to consider most like servers in this industry, the CNC milling machine. You know, big robot arms cut blocks of metal into useful shapes, like, say, for example, this battery cell side for a UAV. They make hundreds of billions of dollars of parts per year, but they require huge amounts of human programming. If you can make these machines autonomous, you can effectively create Amazon Web Services for manufacturing. One click, next day parts, any quantity, super cheap, super reliable. That can drive an industrial revolution if you pull it off over enough machines. So that's what we do.
Excellent. Thank you for that. Yoav, sir.
Hey, thank you. Hi, guys. So I'm CEO, founder of Launchpad, and we care very similarly. We care about autonomous manufacturing. We care about the whole product. So we've spent a fair amount of time looking at different technologies in the value chain, and we think that when it comes to building an entire product, not just a part, that's also difficult. A different level of complexity, a different kind of difficulty, and in particular, we think that it's difficult if you want to make a new product or if you want to make something in low volume where the ecosystem today really doesn't help. If you're Apple and you make millions and millions of units, you've got a lot of people falling over themselves to help you. But if you've got something new you want to make, and I talk about this from personal experience from my last company, it's quite hard, especially if you don't know what you're doing, which was very much my position. And so we've been working on it, and what we want to bring to the world is the ability for somebody who has an idea and a design to very, very quickly, so within minutes rather than weeks, which happens today, to be able to know how it's going to get made and what it's going to cost. And then within weeks, instead of months to a year that happens today, to get a product in their hands. We think there's 3 big pieces we need to bring to the world to make that happen. One is our web app. So this is a place where our customers, anyone who has an idea for a product and a design, can come and upload it, get an immediate feedback for the price and delivery date. 2 is sort of the heart of how we do it, which is our simulation, where, and we can talk about it, but it's effectively a way to be able to figure all these things out without having to program, because we simulate the product, we simulate the machines, put them into a virtual environment, and then through AI and reinforcement learning, figure out the correct things to do. The third thing is our machine that we've designed, which you can sort of see in my virtual background, which is an autonomous assembly machine. So we're very much focused on how do we get all these pieces made, and then how do we bring them together into a product. We think it's really important because if we can do this, we can dramatically reduce the time it takes to make a new product, and reduce the cost involved with labor, which means we should be able to make products locally instead of offshoring more and more, which has really been going on for a decade now.
Yeah, excellent. Thank you. Thank you both. This will be a good conversation. Before we get into the nuts and bolts of what you're doing, let me just ask kind of the standard question this year. You know, obviously we've living through this pandemic. It's in, I know, Theo, you're in Europe. Yoav, you're in California. So I think some experiences there, things are spiking again. So I guess my question is, how's this impacted your operations, and what adjustments have you had to make as a result of it this year? Theo, let's go back to you, sir.
Sure. So I like the Scott Galloway way of thinking of this, which is that COVID is an incredible accelerant for trends that were already happening. So the biggest difference for us is, you know, we now have a primarily remote workforce with flexible working, and we wouldn't have gotten to that for another probably 5 years if it weren't for COVID. You know, we have had to digitalize our communication. We have had to strengthen the way that the company communicates. It's completely changed the way that we manage our business. And now that we are getting to come back together again, you know, things have changed, and they've changed very much for the better. The hardest part of the year was COVID trashed the venture capital funding environment, and it became very, very difficult to raise money this year, which was awful timing for us, but we're through it now. So we will hopefully be into the land of positivity of 2021 with more cash in the system than ever before. Broadly, manufacturing took a really big hit, but I think that recessions are excellent for startups because they tend to wipe out the low performing companies and leave a green field of reduced competition for the stronger companies that remain, those that want to be consolidating. So if you can survive a recession as a high-tech startup, then it's very, very good, puts you in a great place to be coming out on the other side of it.
Excellent. Thank you. Yoav, how's your experience been?
It's a really interesting question because even though I've been thinking about Launchpad and doing work with my partners for a while, we officially formed the company in February of this year. And then 3 weeks later, you know, the first rounds of lockdown started happening. And so on the one hand, nothing changed because everything started this way. So we were already born in this period, which has been super weird, frankly. My last company was, I set up in London, was a green energy company. And fairly similarly, I set that up right as the world was collapsing with the recession. And what that meant was our access to capital was super limited. We had to, from the day one, we had to be incredibly lean and frugal because we didn't have a choice. We didn't have any money. And that gave us this amazing competitive advantage as we grew, because compared to the people that we were competing with, we were dramatically lower cost. I'm talking orders of magnitude, 2 or 3 orders of magnitude in certain cases. And I think that a similar thing is going to happen here, but in a slightly different way. We didn't have a choice, right? I wanted to build a facility and hire a bunch of people and get people together in a room to do programming. And I've been sitting in my living room this whole time and my home office. But, you know, the fact that we're forced to work this way, we've still managed to get an awful lot done. I think that's being sort of fused into our DNA. And I think that going forward, you're going to see that companies that have really embraced this, I think it's going to be a bit like the lean startup movement was. You know, it's going to become essential that you know how to flexibly manage resources and how to automate stuff. And you know, that's a really good thing to have in your DNA when you're part of the autonomous manufacturing world, I think.
Yeah, no, it's exactly what we're talking about. And Eric, I think it's really interesting to have two founders of relatively young startups and actually look at what startups have been through in 2020 and the whole access to capital and what's been going on there. And actually, I think one of the really interesting things about this year is that the manufacturing industry is prepared to listen to new ideas. And when I've talked to particularly CEOs of EMS companies, they've talked about digital transformation and the desire to get on with it, but they've been challenged by this idea of what do we do? What do we do about capital? Because capital's under pressure at the same time. And, you know, as you say, Yoav, when you're in this situation, you become lean and you start to think about how you manage resources. So I think that idea of how do we accelerate digital transformation without spending a lot in cash is really interesting, and that you know, connects to the idea of different business models. But before we get into that, I just wanted to hear from you guys whether you think the COVID situation has underlined that need for digital transformation. Theo, you mentioned the idea that it was an accelerant. Do you think that's because it's exposed weaknesses in traditional manufacturing? Why do you think it has been such a big accelerant this year?
I think the most obvious surface one is people have had to start working remotely and speaking to each other using video conference software, and video conference software is like the first in to using many other kinds of digital and collaboration services. You know, it's much easier to collaborate on, say, Google Sheets, a cloud service, versus Excel when you don't have multiple people in the same room. So it's breeding a transition to more people being more comfortable with collaborative online digital services, and then that experience bleeds out across into people's expectations of how they should work in general. And in an industry like manufacturing, where stuff is typically pen, paper, clunky ERP systems, relies very heavily on tapping people on the shoulder or drawing your Ono circle on the ground and staring at things, this is a good thing.
And
I still do that, by the way. It's a great technique. I don't think you could escape Ono's circle.
The Ono's, I love that.
So, Yoav, when you look at it from your point of view, what do you think that traditional manufacturing has been more challenged by COVID than you would expect a digitally transformed industry to be?
Almost certainly, yes. It's kind of hard to see in the numbers because everyone's focused on people, not financials, and financials are kind of mixed up with a bunch of government support. So eventually it'll sort of, you know, we'll all see it. But I guess you know, if you think about it, right, what is the current system optimized for? It's really optimized for getting things at a really low cost. And what is it sacrificed to do that? It sacrificed flexibility, which when you're dealing with year-long supply, sort of turnarounds, you know, you order. So now we're seeing that Christmas ornaments are out of stock because they placed the orders a year ago, and people are spending more money sort of decorating their houses now because they've got nothing else to do. And so when you have that year-long supply chain, you're really sacrificing flexibility to get lower cost, which is good, except that now when all of a sudden we need a cold chain spun up really quickly in order to distribute the vaccine, that's a problem. It turns out that actually in the West, we're pretty good at tackling those kind of problems, you know, getting flexibility, and not so great at doing things at the lowest possible cost. But I think that we've probably moved too far in the direction of the lowest possible cost and given up too much flexibility, which is kind of what we've seen going on. And that's why the world is suffering so much. And I'm talking globally, not just in manufacturing, but when you look at the most successful companies, they tend not to be the ones that have the lowest possible costs, right? They tend to be the ones that are best suited to adapt to changing market conditions, which is a longer way of saying flexibility. And that's where I'm really hoping we see this accelerating factor. This accelerant is the fact that people will realize that if I can do something in a more flexible way, even if it's a little bit more expensive, if I can then, you know, turn over my inventory faster and actually not have to discount a bunch of stuff that people don't want anymore, maybe that's a better way to compete, and maybe people will invest more in that way of doing things. That's what I'm really hoping, and we want to give them the tools to do that.
I think it's really interesting if you look at what's happened in where we've had disruptions like YouTube. It became incredibly easy to become a content creator. We have had an explosion of hundreds of millions of content creators. Roblox going to IPO next month made it incredibly easy to create video games. You have millions of video game creators, you know, mostly half of them under the age of 16. When you make it really incredibly easy to create something and then let them get something out of it, monetize it back, then you have an explosion in creators. And it's never been possible to have that in manufacturing because it's just so darn hard to make anything. And, you know, 3D printing is not going to be the answer. It needs to be the creation of complex products, that are actually useful. And when we get to that point where it's super easy to design something, it's super easy to make it and get it made in quantity of 1 and then 10 and then 100, I expect we will see that similar explosion in companies, in individual creators pushing physical product out into the world.
So an explosion of creativity, an explosion of innovation is possibly one of the positive byproducts of this year.
Hello. Let me ask though, as I look at both of your companies, you've both chosen a different area to focus on with your solutions here initially. So I'm thinking about your vision of the autonomous manufacturing, your company's role in that, and maybe you can't do it all at once, obviously, the whole ideal of lights out factory, right? That there are no humans in there necessarily. I don't even know if that's an ideal end state. But which processes do you see as being the most applicable to address first? And maybe Theo, that's exactly what you're doing. You decided with the CNC, that was really a simple kind of a low-hanging fruit area.
Yeah, so I think there's 3 layers. There's design the product, there's make the discrete components that go into the product, and then there's assemble those components. And those 3 can be quite closely linked. We have entered in the make the discrete component manufacturing piece autonomous, which is incredibly difficult when you're doing something like CNC. There's a trillion ways of making this with a CNC machine. There is a lot of technical work in making that process autonomous before you can then move on to turning, mill turn, laser cutting, punching, pressing, things that we would assume are actually quite autonomous today, but are not at all. If you can deliver, as we intend, autonomy in the discrete manufacturing processes, then it follows that it should be quite easily possible to link that to the next level in the supply chain of autonomous players like Yoav, doing autonomous assembly, and then linking that together with design, generative design, to create end-to-end autonomous supply chains. So if I think of an industry ideal to get to, I don't actually think of lights out factories. I think that robots are quite overrated in high mix production, and humans are highly underrated. If you look at an Amazon warehouse, software's making all the decisions, but there are still people everywhere doing things. And I think that the factory of the future looks very much like the Amazon warehouse of today. So yeah, I think the ideal end state is the flexible autonomous supply chain. You have autonomous factories, all highly specialized, talking to each other through API. You call from one of the assembly factories what it is that you want to create, and it then queries the global supply chain of autonomous sub-assembly manufacturers and component manufacturers to then autonomously produce those components and sub-assemblies to come into that factory. No human decision making, right from the discrete component manufacturer all the way through to the assembly. That to me is an ideal end state. And eventually it follows that we should get to the point where everything that you need to expand the supply chain is contained within the supply chain, and it can create enough components to expand itself quickly. And that's when you get to exponential manufacturing, which is really exciting.
And that's this vision of this autonomous supply chain actually building the autonomous supply chain. It's that exactly. Future of robots building robots. Yoav, how does that fit in with your philosophy? Because to a degree, your model is that layer that Theo talks about of assembling on top of that, and actually, interrogating the supply chain and finding companies like Theo's that have those parts. Do those models gel very closely together?
Totally. There's a couple of things over there that I really agree with. In particular, the fact that I don't think for a long time it's going to be lights out. For a couple of reasons. One is we use a lot of machine vision, you need light. But also the fact that, people are required, right? Anybody that aims to replace people completely in one step is probably going to fail. I'm not saying definitely, because, maybe it can be done, but I don't think we can do it. So the way that we approach this is very much, there's an entire supply chain we want to link into. I wish that everyone had APIs, and they don't, and they should, and hopefully we'll get there. there's something that happens before the API and after the API as well. So before is very close to the design phase, because when you're talking about an entire product, just because every component can be made a source doesn't necessarily mean the product can come together for a bunch of different reasons. It may not actually be physically possible to put these things together, the clearances, the tolerances, and all that kind of stuff. So a bunch of not design work per se, but this is closer to word checking the margins in your document versus writing the actual words inside. It needs to happen. Word doesn't force you to do it by yourself. It'll do it for you, and it'll resize with the paper. It's not rocket science, but it has to be done, and that's a big part of what we're working on. And then on the other side is actually making things come together. And one of the things that needs to happen is to figure out what can machine do and what is a machine not suited to do, and so a human being should do. We currently think that we're covering around 50% of the actions that happen in a typical product, which leaves 50% to be done by people, which is okay. A little bit like the Amazon warehouse. They used to have way more people working there, and now they have fewer people working. They're doing more specific tasks. Same thing with automotive manufacturing. And I think that's pragmatically the right approach in order to get to this full-blown autonomy. The idea of the supply chain reconfigures itself. So absolutely, I love it. That's exactly where we should get to. What we need, I think, in order to get there is the first stage and the end stage to be working. Otherwise, it's always going to be tempting to go somewhere else. If you need to make 2 steps forward to make 1 step back, no one's going to do it. At least incumbents won't. And so we need to have this sort of layer that is working in its entirety, but shallow rather than for every product. And I think that's probably the way to build up on it. Because if we get 90% of the way there, but the final 10% is missing, it'll go somewhere else that'll be lower cost, and then it'll never happen. That's why we're so focused on the assembly side of things, because that's where products actually come together, assembly and testing.
Yeah,
I think
and if
there
we
was
look
a
at it
really
in terms
interesting
of timing, there's often an ingredient technology that has allowed these revolutions to take place, or these developments to take place. Is it all about artificial intelligence in this case? Is that one of the key ingredient technologies that means now is a good time to be doing this?
For us, it is, right? So we don't use purely AI. I don't think anybody realistically that does things in the real world does, but the stuff that AI can do is just unbelievable. I've been programming for 20 years, and it's really just the last few, not that the algorithms have appeared, right? I was studying these algorithms when I was doing a computer science degree, but the things we can make them do now is just amazing. And you just get into a Tesla, double tap the stalk and see what happens. This could not have happened in a traditional if-then deterministic kind of way of programming stuff. And the thing is, what AI is great is replacing these kind of things that these sort of if-then conditions that would take an infinite amount of time to write. Where it's really bad, or the cost of getting that capability is it needs more data than is fathomable, just an insane amount of data. And part of the problem is that collecting this data in many fields is just not viable. You just cannot collect this level of data. The thing that has changed in the last 3 years is we've now built enough good AI algorithms together with the simulation tools that we can simulate the data to train the AI. And it turns out if you simulate enough data, you get an AI that works really, really well in the real world. That's just a few years old. And that's why we can do what we do.
Theo, the same from your point of view? Is AI the key ingredient technology that you've been using?
No, so I think there's a few things coming together. Compute is getting very, very cheap and very scalable and very easy to access. The Amazon Web Services effect creates an explosion of startups. To us, the problem is a little bit AI, but much more in the realms of computational geometry and high performance algorithms. So, we don't use massive training sets. We don't need data. We have, software engineers sitting in a factory with lasers pointed at cutting tools, building mathematical models and trying to solve the traveling salesman problem in, 35 dimensions. It's a combinatorial optimization problem that's actually quite poorly suited to traditional ML techniques, and that's the reason why, one of the reasons why machining autonomy has been unsolved for so long is if you want to achieve it, you have to build literally everything from scratch. There are no frameworks that you can use. There are no data sets that you can mine. you have to do everything from scratch. So, and I think you'll find that in a lot of cases in manufacturing. There's a lot of hype and excitement around AI as the solution for everything. We all know on the call that it's not the solution for everything. It's an amazing technology, but it's part of the toolbox. It's not the whole toolbox.
Okay. So when we talk about these things, we tend to talk in terms. We tend to talk in things like Industry 4.0, and a lot of people are disappointed with Industry 4.0. And I know, Eric, you've done numerous calls with the EMS guys that have been like, show me the money, show me the proof case, show me the dividend of Industry 4.0. And I know when we look to autonomy, some people are using the term Industry 5.0. Do you think that's the right way to go? Do you think this is a completely different argument to the Industry 4.0 digital transformation argument? Yoav, maybe you can take that one first.
I don't care that much about labels, and so if it's a branding exercise, I'm probably not the best person to ask. I was telling you before the call, I think the iPhone really hit its stride with the iPhone 5, so that may be a good thing. But maybe just drawing a parallel with the green energy industry, which is where I spent a lot of time. People were very, very disappointed in how expensive renewables were until one day they became unbelievably cheap, and the majority of new capacity, at least unsubsidized, is now built with renewable energy. And I think that there's almost like a quantum state. You need to get to a certain level before it becomes really great, and then everybody switches to it. I think autonomous is probably that thing, because if through automation, what you do is you replace relatively inexpensive labor with relatively expensive programming, that isn't going to work in many, many places. But as soon as you can replace that expensive programming and make it so that you can not need to program at all, that should make dramatic differences. And yeah, I think a lot of people oversold the value of data as if data itself has a value, and it doesn't, right? Even information itself doesn't have a value. So data turns into information, information turns into decisions. But if you don't articulate what those decisions are, no value will show up. And I think so many people got caught in predictive maintenance as the be all and end all of value. It's not enough.
Yeah, absolutely not. Theo, Industry 4.0, Industry 5.0, where do you see this whole industrial revolution discussion?
I don't think manufacturing's finished with Industry 3 yet. I think it's far too early to move on to 5. And my reasoning is there are 3 rules for what classes an industrial revolution. Rule number 1, it usually takes about 100 years, historically. Rule number 2, it needs to result in a multi-order of magnitude improvement in productivity. And rule number 3, it needs to touch all industries. It needs to completely change our way of life across almost everything. Industrial revolution number 1, mechanization, steam power, multi-order of magnitude improvement that touches everything. Industrial revolution number 2, mass production, combustion engine, instant communication. Again, about 100 years transition from those things being created to really delivering value. Number 3, compute, and then the digital revolution. And that's the one that we're still in today. Now, the reason I particularly dislike the Industry 4 term specific to manufacturing is Industry 4 is a digitalization of manufacturing, but that's just manufacturing catching up to what e-commerce and logistics and all of these other industries have already been doing. We haven't even caught up to them yet. So I say we're still in Industry 3, which makes Industry 4, to Yoav's point quite neatly, the autonomy revolution. The last one was compute and digital. The next one is autonomy. And the companies that really interest me across every space are those that are solving the problem of programming is expensive. How can we make it so that a system, be it software or be it a robot arm, can do something, make something that is never seen before without human instruction? So that, for me, is going to be Industry 4. I think when historians look back from 500 years from now, they will class Industry 4 as the period from late to mid early 2000s all the way through to 2100.
Wow, that's a long time frame.
Yeah, these things take a while.
I always like the discussion of the 4.123 4.0 because some pointed out that we're still operating under management 1.0, right? So there's always, in my mind, my background psychology. So I always figure humans are kind of the confounding variable in most things in life, right? It's businesses tends to be rational, how to do these things, but then we enter the humans, and that's where, and I guess that leads to my question is, as we move forward, what are the main inhibitors that you run into in rolling out your solutions? Oh, I'm
Yoav, do you want to take that?
Sure. So we're really focused on the technical problems at the moment, way more than building up a mass customer base, because we are so early. And so that kind of means that the customers that I am working with are early adopters, which are, the best kind of customers. I love early adopters. Nothing's better than speaking to somebody that already wants to try something new. So we probably haven't hit the, that speed bump of wait a second. And, I say this as I don't sound like it, but I'm a Brit, and moving to America and dealing with Americans, much more willing to engage with something new and try something innovative. So probably I don't have a good answer for that one yet. Ask me again in a couple of years.
Yeah, this is an interesting one, and I think it ties to why has manufacturing been so slow to adopt digital technologies in general, and it's a bit of a follow the money question. If you are a mass manufacturer, if you are one of the incumbents, then you have a lot of money, but you also have very tight margins, and you don't really have the need for autonomous manufacturing because you're making mass production. You don't need to be super flexible. There just aren't huge rewards. Whereas if you're in the 90% of the market that is low to medium to large mix, then that market is so incredibly fragmented, and every factory is so different from every other factory, that to build software that makes those factories autonomous is virtually impossible. It would be like trying to build an autonomous vehicle kit to go on any car. Like, it's possible, but it's completely impractical, and it will take decades. And so what we found is that you can't look to a big company like Autodesk or Dassault and expect them to deliver an autonomous manufacturing solution, because they'd need to make something that works for everybody. So we won't see that innovation from the incumbent software providers. We won't see it from the mass manufacturers. The only place it really leaves you is you need to start building vertically integrated tech manufacturing companies, like what Yoav and I are building, like Bright Machines, like MTech, companies that build the autonomous software and they control the manufacturing process together. That is the only way that you can build an autonomous system. But the benefits to those are so large that you can attract the funding, you can attract the talent, because it's interesting to work on, and it is what you need to deliver a multi-order of magnitude improvement in price, in lead time, in general service levels. So I think that all of this innovation will come out of startups.
I think Theo's totally right. If you think about it, if you're a big company, then you service a wide variety of customers, and you've got to do a great job for all of them. Otherwise, your reputation's on the line. But that means that in order to get a big improvement, you need to boil the ocean in one go, which is impossible, especially when you're a big company that is not necessarily so great in innovation, for all the reasons big companies aren't so great in innovation. And I think that certainly the way we approach stuff is we know that this is a big challenge, and we know that the only way to possibly make it work is to start off super constrained, which means saying no to almost everything, right? Almost any product that can get made, we shouldn't make. We should only make the small subset of ones that really fit what we're doing. If we already have a big customer base, that means saying no to 90% of them, maybe even more. And what kind of big company can tolerate that? So it's really hard. It's really hard. We're not the first people in history to experience this kind of dynamic, though, right? Look at the early stages of democratizing compute, right? The computer revolution. The first PC was garbage compared to mainframes, right? Which is why IBM never put much money behind them, until they suddenly saw that actually the garbage that they could do was really, really important, and then they raced to make the IBM PC to compete with Apple. But the innovation didn't come from them. Ironically, it came originally from Xerox, a paper company that also didn't want to disrupt what they were doing with paper, and so they gave the whole thing to Apple unwittingly.
Yeah, no, it's a curious one. And when you talk about those different layers, I'm kind of curious as to what you both see as timelines and what you see as the stages on those timelines to autonomy. Because I think when I look at, it's the same as the digital transformation. You start with a machine, then you maybe go to a factory, then you go to, or you go to a line, then you go to a factory, then you go to an ecosystem. Is it kind of doing things stage by stage? Like in your case, Theo, is it, how do you make a single CNC machine fully autonomous first, and then how do you make a factory with half a dozen machines in, and then how do you scale that across multiple locations?
So two questions there. I'll answer the second one first. How do we do it? We are building a copy-pastable blueprint, whereby the machine is autonomous. Can't do everything. We still need extremely expert humans in order to fill in the gaps. But ultimately, the unit economics and the service levels are fundamentally changed. The overall factory operating system is in place to orchestrate the copying and pasting. So we don't pay a price for scaling up like you traditionally do as a manufacturer. In terms of the timeline, it comes down to, one, you can look at companies like Amazon and how long it took for them to become as big as they have been. It's not very long, 30 years in order to become the company that they are. I think that we'll see a similar pattern in manufacturing as soon as the investment starts flowing in. And over the last few years, for the first time, we have seen mega rounds going into Industry 4.0 companies, multi-$100 million investments. This is ultimately what it takes to build big companies, no matter what industry you're in. But manufacturing has never had access to that kind of capital. But the world of venture capitalists and growth investors are finally waking up to the fact that there is a multi-trillion-dollar opportunity in manufacturing, and there's a very, very small number of companies prosecuting on this opportunity, and there's a chance for them to make big money. That trend, I think, started 5 years ago. It accelerated over the last 2, and next year, I think you'll see more investment in this space than ever before. It started at the seed stage, and it's making its way up to bigger investors. So I think that the starting gun has been fired.
Yeah, I think it's really fascinating that we've started to see some funds that are very specifically focused on manufacturing. And you both mentioned companies like like Bright Machines, which I think is funded by Eclipse Ventures, and numerous companies in the automation space, numerous companies in the manufacturing space, and then an investment team that's got a background in manufacturing. And we've seen several other investment groups doing that. Yoav, from your point of view, what are the gears you need to go through, and what's the timeline as you look forward?
I guess I think about it in 2 different ways. So one is as a company, and 2 is as an industry, and they have to be separate, right? When you're thinking about a company, you have to be thinking 1 year ahead and 5 years ahead, and typically no longer, because kind of like Theo says, a lot of this is driven by investors, and investors don't want to hear in 30 years I'll do whatever, because in 30 years they will be long gone. So as a company, we do think about things in short-term increments and what is it we can achieve. But really, when you think about sort of the industry and the sort of the bigger picture, I think a lot of this is going to be driven by people. But like Eric says, this at the end of the day is people, and a lot of the timings just have to do with how quickly people change. And I think one level of abstraction up from that is really policy. So technology is sort of one step, but I think that's a bigger one. And if you look at, how long did it take for China to go from making the cheapest plastic parts to being the manufacturer, the first and last place to manufacture things? It took about 20 years, maybe 30, depending how you want to look at it. And the bridge was, the sort of the crossing point between the US being the largest manufacturer in the world and China being the largest manufacturer in the world was in 2010. It wasn't that long ago. So we went from 2010, where China was maybe the place where you do things, to today where it's absolutely default. There's no question about it. 10 years. It's not that long. And I think that a 10-year period should be enough time to be able to dramatically change things, especially because a lot of the technology is here. It needs to be applied, and application means resources, and resources means funding, and funding means focus. So I think, you know, if Theo's right and the starting gun has been fired, I don't think we need to wait 30 years. I think we'll see some dramatic changes in the next 10.
And do you think there's a government policy element in that? There's a lot of people in talking about manufacturing as key to recovery at the moment. New president coming in the US with his own made in USA manufacturing policies. Do you think there's an important role there for government to play to either incentivize what you're doing and this whole transformation, or to stay out your way and allow you to do it, or to, you know, or to put funding into infrastructure? What is it that government should be doing to help on this? And Yoav, you've worked in the US and the UK, so you've seen kind of two different views of that. We'll start with you on that one, if we may.
Yeah. So yes, I think so, and I say this as a you know, diehard libertarian, and so it really pains me. But I spent 15 years in the energy space, in green energy in particular, and I saw what happened when and continues to happen when governments say one thing and do another, is probably the easiest way to put it. And 15 years ago, we could have absolutely solved climate change. And now we're at the very, very end of not being able to do it anymore for no good economic reason, right? Renewables became cheaper than fossil fuels 5-6 years ago. And it doesn't make sense. But when you look at it, you realize why it does, because of direct subsidies, indirect subsidies in the energy space, which I'm not going to talk about here, but, you know, get me started and I will, right? It's kind of similar in almost every space, but in manufacturing, look, we have, you know, China in particular, but a number of other countries which have decided to direct their economy towards winning this game, and with a bunch of direct and indirect support to do it. Direct support being subsidizing of particular companies, indirect support being manipulation of currencies. This is all true. And pretending like it's not doesn't fix anything. And this is strategically important. So yeah, I do think government has some stuff to do. I don't think they've got it right. I've read through the sort of the various things that the current incoming administration is going to do, and some of it's great, but it's not enough. And a lot of it doesn't have any teeth. And when I say it doesn't have any teeth, the Made in America thing is a really good example. That program's existed for a long time, but it's probably a good one to do if it's done right. If it's done wrong, it's going to be terrible. Like every government thing, the libertarian is you know, saying. But if it's done right, then it can be a massive accelerant. And I think we should take the opportunity, especially now, because we are reshifting the way we're doing stuff. We are moving towards more flexible things that COVID has sort of forced us to. We can do it, and we can do it right, and it'll make a big difference.
What do you think, Leo? Role of government, role of administration in terms of enabling this kind of thing, or contributing in some way?
So I can only speak from the perspective of the UK, and I think that the UK government has done a lot of things that we have benefited from to encourage R&D, you know, to encourage venture capital investment, to encourage angel investment. They've issued grants, they issue massive R&D tax credits. If you have a lot of software engineers working on IP, you get tax breaks if you're filing patents. They have a nationwide network of what are called the high value manufacturing catapults, you know, centers of excellence with hundreds of researchers and hundreds of millions of pounds worth of equipment in them, all of this to try and foster advanced manufacturing innovation. So we've been a real beneficiary to these things, and I think that at least where I stand, you know, that has helped us immensely and has made the UK an amazing place to start an advanced manufacturing tech company. You've got it all. You've got a really strong software engineering ecosystem. You've got a great funding ecosystem. You've got a big manufacturing industry that tends towards advanced manufacturing with those skills you need as well. So that's all good. The one thing that I would love to see is something a bit like the open banking standard, you know, which has forced in the UK banks to make data available, which has caused an explosion in fintech startups by, you know, unleashing that data. We don't really have an equivalent in manufacturing. You know, think how crazy it is that you cannot send a step file today that contains hole and geometric tolerancing information in it as standard out of a CAD package. You've got to pay for that. That is absolute insanity, and that is replicated across almost all kinds of equipment and software package, which is why it's so difficult to integrate software in this industry. Everyone is quite literally speaking different languages, and when there are not sufficiently well aligned private sector incentives to move towards standardization on data interchange, it's time for government to step in. And so that is something which I doubt we're going to see, but that would certainly be at the top of my wish list after the other things.
Yeah, so that's that drive to things like CFX to get everything connected, everything focused on the same kind of thing. Hey, Eric, have you ever done a panel with 3 Brits, albeit 2 displaced Brits on?
No, I'm just overwhelmed here. So
there you go. It's always going to happen. We should wrap up with some vision for 2021, Eric.
Yeah, no, absolutely, gentlemen. I mean, this could go on and on, but we all have other obligations, I'm sure. Yeah, let's speak to that. What is it? There's the long-term strategy which you're all working towards, but just think forward a year, 2021. What can we expect? What are you seeing in the next year for yourselves?
So 2021 is going to be very big for us because we're going to come out of our very, very quiet beta and we're going to start engaging with more customers. So I'm really, really, really excited to start seeing just a dramatic variety of products coming into our system and helping people, ideally really helping people that are launching something new. That's been the most fun stuff so far, is to work with somebody that's got an idea for a new product. They've got a prototype that they've 3D printed and assembled, and just didn't know how to take that next step. And especially anybody that's been in manufacturing for a while, they know that eventually you end up spending months and months in an overseas factory. And I don't think we're going to be at that point next year. I don't think people are going to want to spend months in factories in China and not yet. And I'd love to be able to take those people that otherwise wouldn't be able to take their product to market and bring them to market and make it here in America. Can't wait for that.
Excellent. Theo?
So next year is going to be a very exciting year for us as well. We've been working on solving the machining autonomy problem for more than 5 years now. And my co-founder used an analogy the other day, which I loved, which was SpaceX had to blow up a lot of rockets before they got the one that really flew all of the way. We've blown up a lot of rockets in the first 5 years of the business, but the release that we're working on right now, which is going to be ready in just a few months, that's our first real flying rocket. And that matches with other flying rockets that are coming in our overall factory operating system, like our autonomous scheduler. Many things all come together to stop our factory from looking like a accelerated typical factory and start making it look like a next generation autonomous factory. That's literally right around the corner. So that is a very exciting time for us. More broadly across industry, I'm looking forward to seeing an economic recovery. I'm looking forward to see where all of that enormous amounts of capital that are currently sloshing around the system goes. Hopefully not into lots of pointless SPACs, hopefully into some really exciting tech companies. Overall, I think that the companies that survived this period are going to come out, harder, leaner, meaner. They're going to be there to exploit the opportunity, and we'll see some really big winners out of it.
Yeah, I think it's really interesting what you say there, Theo, about companies coming out of the crisis and how they've become leaner and meaner. And Yoav talked about this a little bit in terms of, being a lean startup and managing your resource. And that's one of my hopes in 2021, that the companies that have come through the crisis are better for it, are stronger for it, and maybe we are as individuals. You always hope with something like this that people learn from it, like every other crisis, and then 5 years on you think, really, do we remember what happened there? Do we remember what happened with the last downturn, and we ignored all the signs, and we seem to be doing it again? But yeah, I think that's my big hope, that we manage to harness some of that innovation and creativity that's been in abundance this year, and really do something with it in 2021.
Okay. Well, gentlemen, thank you all for your participation today, for sharing introducing us to your companies and giving some updates on what's to come. I will say to the audience there, there's an individual interview with both Theo and Yoav on EMSNOW. If you want to check their sites, you can learn a little bit more about each of them or go to their particular websites as well, as I have in preparation for this. So, but reach out to these gentlemen if what they're talking about resonates with you. You can get a hold of them through LinkedIn as well, I'm sure. So, gentlemen, thank you again for your time. Hopefully we can catch up in 2021 and get some updates from both of you. I think that would be excellent. So, so let me just say again, thank you, and I wish you all a safe and happy holidays.
Thanks, Eric.